Hello, welcome to Program with Sam, and this is C Lesson 4. So, up until this point, we've been using header files that are provided as standard with C. They're C standard libraries. But what if we wanted to make our own header file, and we wanted it to have functions that we could then include in our other projects? Well, that's what we're going to be looking at today. We're going to be looking at the creation of header files, how they work, and then how we can actually use them in our applications. So firstly, the first thing we're going to want to do is we're going to want to create a header file and give it a name. Now in Visual Studio we can do this by right-clicking here and just adding a file. But for in this particular project, we have to do it inside the header file, header files folder. So we right-click, add, new item, let it load, and then we're doing a header file, and we're going to call it mathfuncs.h. So that's mathfuncs.h created, and you'll see it has this thing pragma once. That's just to do with the compiler. It's basically ensuring that you're not including multiple copies of the same header files. So if we include, say, like iostream here or something, or standard stdio.h here, and then we also included it in lesson 4, it would resolve some of the errors that you may experience there. So we've got our header file, but we haven't written any functions yet. We haven't declared anything. Nothing's happened. So for the purposes of this, we're going to declare the four sort of like basic mathematical functions. So we'll do and we'll have it operate with doubles. So it'll say double add, and it will take a double A and a double B. Then we'll also have double subtract, and we'll call it double A, double B. We'll also have add, the double multiply, and double B, and lastly divide, which will have double A and double B. Now you'll notice that we've not actually defined any of the function here. All we've done is declared that it exists, and it's now popping up with this sort of green wiggly line underneath. And if we right click and do quick actions, it says create definition of add in mathsfuncs.cpp. And this is because it needs a separate source file to be linked to the header file that has all of the function definitions in. That's the good practice. That's the way it normally works. So if we then create a new item and we do a C++ file, a C file would work as well, but because of the fact that this is a C++ compiler, we're just using it for the simplicity's sake, and we call it mathfuncs.h. Has to have the same name so that they can be linked. Not H, CPP, sorry, I'm an idiot. mathfuncs.cpp. Then, if we hashtag include mathfuncs.h, and if we could spell include correctly, that'd be terrific too. We're now ready to actually start defining in the file. So if we right click, quick actions, create a definition there. If we go back into this file, we can see now that we've got the actual definition body of the function there. So if we go back here and we'll just quick refactor and create a definition for all of these functions in the CPP or the C file if you're doing it on Linux and are using C normally. Then if we go into the lesson 4, mathsfuncs, we have all of the function bodies ready to be written. So now we're going to actually write the function bodies. So in this instance, it's just A plus B. And then in this instance, it's just A minus B. And then multiply will just be A times B. And divide will just be A over B. And the reason we've gone for doubles instead of ints is because if you try dividing ints and returning an int, it won't work. Okay, so with that in mind, now we're ready to try and include it in our main file. So what we can do is we can go include, and we can type in mathsfuncs.h. Note how I'm using the speech marks as opposed to the sort of less than or greater than symbols. That's because those are used for when the libraries come standard packaged with C. If you're using an external header or something, it's more common practice to use the speech marks. then we can actually write tests to use the functions. So we could declare double x, y, and z, and then we could say x is equal to 2 and y is equal to 3, and then we could say z is equal to add x, y, and then we'll need an outputting class, so we can include, and this is where we see these ones, stdio.h. If I could spell. Oh my gosh, what's with me today? So there we've got that library included. We can now use printf, and we can say adding %d and %d equals %d, and then we would have x, y, z. And this can follow the same principle to get all of our things. We can do z is equal to subtract x, y, and then we can say printf subtracting %d from %d equals %d, and then obviously fill it in again, x, y, z. And we'll do this, and what I'll do is I'll finish doing this for the remainder of the tests, and then we'll run it and we'll see what we get. Okay, so I've gone ahead and finished writing up the test functions and the outputs of them. It's worth noting that I did actually get it wrong. I was using %d in the printf statement. You want to be using %f. If you try and run it with %d, you'll get an error of sorts, or rather it'll run, but warnings will pop up because %t is for an integer and %f is for a decimal or a float. Or a double or a float, rather, I should say. Decimal point number. So that's something to bear in mind. I also added new lines because if you run it otherwise, it will just be one long string and you won't be able to read the information very clearly. So with that in mind, we're now actually ready to give it a test run. So if we just run it on the local debugger, we get the output. So we say adding 2 plus 3 equals 5. Subtracting 2 from 3 equals -1. So that should be the other way round. Subtracting 3 from 2 should be the other way around, but we get the gist of it because we pass the arguments the right way around. And multiplying 2 by 3 equals 6, and dividing 2 by 3 is equal to 0 by 0. Subtracting 2 from 3. Yeah, wait, no, it is the wrong way around. It should be subtracting 3 from 2. Yeah, but that's just the semantics of the sentence. It's fine. It's not a big deal. But you get the idea, and that's how it works. And so that about covers it. We've in this tutorial we've shown you how to create your own header file and define and declare your functions within it. And you're ready to go off and build your sort of own libraries or reusable code that you want to use throughout your projects. And that's it for this time. Next time we're going to be looking at loops in C. We're going to be looking at conditional statements in C. And we're also going to give you a sort of warning about goto and basically not to use it. But we'll show it off and sort of tell you why it is poor practice to use. If you'd like to follow me at ProgramSamBlog or follow the blog directly at programwithsam.code.blog, that would be much appreciated. And I will see you all in the next one.